In this video, I'm going to take some carbon emission data and put it into Excel and plot it and then fit it to a quadratic polynomial. So here we go. So I took this data from macro churns. This is sort of the carbon emission data versus year for the US. I'm going to copy this down. I have it copied it from the web to Word. I'm copying it over to Excel, match. Okay. And first thing is I don't want the metric tons per capita data, so I'm just going to delete that. And then years are always funny because they start so high. So the earliest date is 1990. So I'm going to insert a column and subtract the years and figure out not the actual year, but the years since 1990. I'm going to subtract 1990. Okay. So let me highlight B, insert. So there's a column, and I'll say years since 1990. Maybe I'll right click and format that column, and with alignment, I'll wrap. Okay. And then I'm just going to enter here equals our year minus 1990. So now our years are not starting in the thousands, but they're 0 to 30. So a little more reasonable values. I also have some issues here with the amount of carbon emissions, unfortunately, is so very high. And even in kilotons, it's quite high, up in the millions. So again, to sort of bring the numbers down, I'm going to convert to an even bigger unit. So I'm going to go from kiloton, even past megaton, into gigaton. So I'm going to divide by 1,000,000. So I'm going to say gigatons of the CO2, not C parenthesis 2, CO2. There we go. Okay. And so that is equal to, in this case, C2 divided by 1, and 1, 2, 3, 1, 2, 3. And get the thin cross and paste that down. Okay. So now I want gigatons of carbon emissions versus years since 1990. So those two columns are not next to each other. So I can sort of copy and paste the data. That's one way, is I could copy this data and then paste values and put them next to each other. But I'm just going to highlight column B. And then I'm going to hold down my control and highlight column D. Make sure if I have a header in one, I have a header in the other. I have to be sort of consistent. I let go of control once I have the two highlighted. And then I'm going to go to insert XY scatter. There we go. All right. And let's do, I like quick layout number 9. This axis, x-axis was years since 1990. This axis was, let's say, carbon emissions in gigatons. Okay. And, all right. And we'll say this is US CO2 emissions for title. Typing very well. Emissions, there we go. I don't like legends very much. This one's not very useful because it's just telling us information that's already, like, if it brings in extra information, I'm all for it, but it's just repeating the information that's already sort of obvious from it just being a graph of what it's a graph of. Now I want to, this is not a very good R squared here, and we can see it went up And then it's starting to come down. Hopefully that trend will continue. Let's format the trend line here, and we want this as an example of a quadratic. So let's go with polynomial. And now the r squared's jumped up to 83, so that's much better fit. And that's what we wanted to show. Okay, so paste the data over to Excel, done. Year since 1990, done. Just move it to gigatons, make the plot, polynomial over 2, paste the graph below. So take this graph, paste it over into from Excel to Word. And there's always this very wide range of pictures. I'm going to go with the picture one. Now, some of those versions of pasting, like if you edit the Excel, then the word will change, and I usually don't want that. So this was my paste as a picture. Okay. And now we just have some questions to answer to make sure we understand the parameters of the polynomial fit. So which one is the constant? That's the one without any variable x representing the years since 1990. So the constant coefficient is 4.7481, and that is all by itself a y, and so that is gigatons. The linear coefficient is the coefficient of x, so that's 0.127. And that's sort of like a slope. And so it's a rise over a run, or another way to say it is that this 0.127 times x as a unit, as a combination, has to have units of gigatons, and x has units of years, so the 127 has to be gigatons per year, so that the years in the denominator of the 0.127 and the years in the x cancel each other. We're just left with gigatons when we multiply them. And then the quadratic coefficient is minus 0.0046. It's the coefficient of the square term. And we can play that game again. That combination, that number times x squared, where x is years, has to give us gigatons. And so that gives us gigatons per year squared. Just do it like that. All right. So that's it for that exercise. Thanks much for your attention.